Hello children, this is Suresh Sukarma presenting Divine Public School in the e-learning classes. Subject Mathematics of class 10th and chapter number 3, which is pair of linear equations in two variables. So the children, this is the part number 3. And in this module we are going to learn about the thing which is first one is the geometrical method of solution of pair of linear equations in two variables. And algebraic conditions for the lines of equations have intersecting, coincident and parallel. Afterwards we will see the example number 4. So after studying these conditions, you are able to solve the exercise 3.2. Let us see the first condition, geometrical method of solution of pair of linear equation of two variables. So in the geometrical representation of pair of linear equation of two variables, as in the last session we have discussed few things related to this geometrical representation. Those things we are going to learn here in the new form. Let us see what are these. So the first condition was two lines will intersect at one point. It means a pair of linear equations in two variables which has a solution is called consistent pair of linear equations. It means equations have unique solution. As you have seen in the last session, the lines which are intersecting at one point. So the lines which are intersecting at one point is called the consistent pair of equations, and it has unique solution, means one solutions. So the students, this you have read in the last session, and here also we are going to revise. Okay, see the second condition. In this, a pair of linear equations which has no solutions. So the children, as you have read in the last session, the lines which have no solutions, it means the lines are parallel, means they are not intersecting, and these lines are called inconsistent. These equations are called inconsistent pair of linear equations, and the line may be parallel. In this case the equations have no solution, and these equations are called inconsistent pair of equations. And the figure will be this is the line first equation, this is second equation, and they are parallel to each other. Now see the third condition. In third, the two lines will be coincident. Coincident means overlapping to each other when the equations have infinitely many solutions. Means a pair of linear equations which are equivalent has infinite many solutions, many distinct common solutions. Such a pair of linear equations, such a pair of equations is called dependent or consistent pair of linear equations. So here also you are, when you are getting the solutions, so the equation pair of equations are called consistent, and when the pair of equations is not giving the solution, so in that equation, in that condition, the equations are called inconsistent. So these children, be careful here in this condition. Now see, here the figure means both the lines are overlapping to each other. It means they are coinciding to each other. So producing infinitely many solutions, and since they are producing solutions, therefore it is called consistent, and one equation is dependent on the second equation. That's why both the equations is called dependent equations. Okay children, now let us see how to understand and how to recognize the algebraic conditions for these linear equations, for the lines of these equations have intersecting, and when they will coincident, and when they will be parallel. Algebraically we have to understand. So for getting these intersecting, coincident and parallel, we have to do few important things which is related to the general form of both linear equations. Okay, so as you know that the general form of a pair of linear equations in two variables x and y is given a1x plus b1y plus c1 equals to 0, which is equation number 1, and a2x plus b2y plus c2 equals to 0, which is equation number 2. So in equation number 1, a1 is the coefficient of x, b1 is the coefficient of y, and c1 is the constant term. In equation number 2, a2 is the coefficient of x, b2 is the coefficient of y, and c2 is the constant term. Here a1, b1 and c1 are the real numbers of the equation number 1, and a2, b2 and c2, they denote the coefficients of both the equations. Okay children, now the concept is based on these coefficients. So how to recognize when that the lines will be intersecting, which is depend on these coefficients, and when the line is coincident, when the line is parallel. So let us see what are those conditions based on which that you can recognize. So let us now write down the compare of these coefficients. The values of these coefficients means a1 upon a2, b1 upon b2 and c1 upon c2. Means from the general form, first we have to find out the value of a1, a2, b1, b2 and c1, c2. Afterwards we have to compare these coefficients a1 by a2. Means we have to find out the value of a1 upon a2, b1 upon b2 and c1 upon c2. Okay children, after getting the values of these a1 upon a2, b1 upon b2 and c1 upon c2, let us see what will happen. Now the first condition is when you are getting what you are getting, a1 upon a2 is not equals to b1 upon b2. Means this first is not equals to the second. If this condition you are getting, so the lines will be intersecting. Means both the lines intersect each other, and they have unique solutions, and the equations are called consistent. Children, here you be careful these condition and learn the condition according to their result. Now let us see the second condition. When the values of a1 upon a2 will be equals to b1 upon b2 and is not equals to c1 upon c2, if relation, that comparison between these coefficients, if a1 upon a2 equals to b1 upon b2 is not equals to c1 upon c2, then what will happen? Let us see with the line. So the lines will be parallel to each other. they have, it means if they are parallel, it means they have no solutions. So the equations are called inconsistent. Now see the third condition. In this, when a1 upon a2 equals to b1 upon b2 equals to c1 upon c2, it means all three comparisons are equal, then what will happen with the lines? Lines will be coincident, means both the lines are same and they are overlapping to each other, having infinitely many solutions, and these equations are called consistent again. Just see, in this condition, in intersecting and in infinitely many solutions, means having unique solution and many solutions, then the equations are called consistent, means when the equations are producing solution, then they are called consistent, and the equations are not producing, means having no solution, so the equations are called inconsistent. Understood? Now children, let us understand these conditions based on your previous examples. Let us now go back to the pairs of linear equations formed in the example number 1, 2 and 3 that you have read in the last session, and note down the what kind of pair that they are graphically, that you have drawn it. Okay, so in the first example, your equation was x minus 2y equals to 0 and 3x plus 4y minus 20 is equals to 0. So from the graph you got the result, the lines are intersecting. In the second example, your equations were 2x plus 3y minus 9 equals to 0 and 4x plus 6y minus 18 equals to 0. Then from graphically you got the result, the lines were coincident, means they are overlapping to each other. In third, you got the equations x plus 2y minus 4 equals to 0 and 2x plus 4y minus 12 equals to 0. Then from the graph you got the lines are parallel. Now let us understand this algebraically also. Okay, so here are all three pairs of equations are given in the serial number 1, 2, 3 and the pair of lines. So let us understand the first pair of equation, means it was the example number 1. In this we have to find out the value of a1 upon a2, means a1 is the coefficient of x in first equation, a2 is the coefficient of x from the second equation. So a1 upon a2 is 1 upon 3. Similarly, b1 upon b2 is, b1 is the coefficient of y from first, b2 is the coefficient of y from the second equation. So you got minus 2 upon 4, which is minus 1 upon 2, and c1 upon c2 means 0 upon minus 20. So here the condition, what are you getting? This 1 upon, is this 1 upon 3 equals to minus 2 upon 4? No, they are not equal. Therefore a1 upon a2 is not equals to b1 upon b2. After comparison, then the graphical representation, you got the intersecting lines, and here algebraic interpretation is giving exactly one solution, means unique solutions. Let us come on the example number 2. The equations were 2x plus 3y minus 9 equals to 0 and 4x plus 6y minus 18 equals to 0. Let us see the value of a1 upon a2. a1 upon a2 is 2 upon 4, b1 upon b2 is 3, c1 upon c2 is minus 9 upon minus 18. After getting the comparison between the ratios of the coefficients, this 2 by 4 equals to 1 upon 2, and this 3 by 6 is also equals to 1 upon 2, and minus 9 upon 18 is also equals to 1 upon 2. Means all the values of a1 upon a2 equals to b1 upon b2 equals to c1 upon c2. Therefore, if they are equal, from the graphically you have confirmed that the lines were coincident, and here algebraic method is also giving infinitely many solutions. It means both the lines are overlapping to each other. Now let us move on the example number 3. In this the lines were x plus 2y minus 4 equals to 0. Second, 2x plus 4y minus 12 equals to 0. Let us find the value of a1 upon a2 means 1 upon 2. b1 upon b2 is 2 upon 4 and c1 upon c2 is minus 4 upon minus 12. This is 1 upon 2. This is 2 by 4 is also equals to 1 upon 2. But this minus 4 upon minus 12 is equals to 1 upon 3. It means a1 upon a2 equals to b1 upon b2, but this c1 upon c2 is not equal. Therefore, graphically you saw that the lines were parallel, and here the lines are also parallel, having no solutions. So the children, you have to learn these conditions according to their graphical and algebraic interpretations. Now let us see the example number 4. In this, given that, check whether the pair of equations are x plus 3y equals to 6, first equation, and 2x minus 3y equals to 12, this is the second equations. Okay, now we are going to check here, are these equations consistent? If so, solve them graphically. It means if they are consistent means producing solutions, either it is of unique solution or it is of infinitely many solutions, then the equations are said to be consistent. So let us check, which is based on the coefficients of these equations. Okay children, so let us see the coefficients first. Okay, here from the first equation, coefficient of x is 1, means a1 is 1, b1 is plus 3 and c1 is minus 6. From the second equation, a2 is 2, b2 is minus 3 and c2 is minus 12. So let us check the solution of it. Let us draw the graph of both the equations, equation 1 and equation 2. So for this, to draw the graph, we find at least two solutions of each of the equations. After getting the two solutions, then we can draw easily the graph. So for the first equation, x plus 3y equals to 6, we got these two solutions, 0, 2 and 6, 0. You can check it easily that you are able to solve this equation. How this 0 and 2, how this is 6 and 0. Now from the second equation, 2x minus 3y equals to 12, you got these two solutions, 0 minus 4 and 3 minus 2. Let us plot these lines. This is 0, 2, 6, 0 and 0 minus 4 and 3 minus 2, and draw both the lines. After plotting, say A is 0, 2, B is 6, 0, P is 0 minus 4 and Q is 3 minus 2 on the graph paper, and join the points to draw the lines AB and PQ, so that in the view, this is A which is 0, 2 and it is B which is 6, 0, and then draw this line AB. Then P is 0 minus 4 and Q is here which is 3 minus 2, and join this PQ, you will get this line. Now let us see, both the lines are intersecting at point B. So this point is the solution of this equation. So we observe that there is a point B whose coordinate is 6, 0 is common to both of the lines AB and PQ. So the solution of pair of the equation of line is x is equals to c 6 and y is equals to 0. It means both the pairs of equations is consistent. Understood? Thank you.